What if you could stand on the surface of the sun for 1 nanosecond, just a billionth of a second, and somehow walk away? Sounds impossible, right? Let's test that idea. First, which surface are we talking about? The sun's visible surface. The photosphere sits at about 5,780 Kelvin. That's roughly 5,500 degrees Celsius. That's hot enough to melt and vaporize anything we know. But temperature alone isn't the whole story. The sun's surface emits about 6.3 times 10 to the 7th watts per square meter. That's from the Stefan-Boltzmann law. In 1 nanosecond, that's only about 0.06 joules per square meter. Tiny. So pure black-body radiation alone doesn't dump enough energy in a single nanosecond to flash cook a person. The real killers are atomic and molecular physics. Chemical bonds vibrate and break on femtosecond to picosecond time scales. That's 10 to the minus 15 to 10 to the minus 12 seconds. Electrons get stripped, and atoms ionize in femto to picoseconds too. In other words, the sun's environment rips molecules apart far faster than a nanosecond. If you were placed in the photosphere, you'd be hit not only by photons, but by a dense, scorching gas of atoms and ions. Collisions would strip electrons, vaporize tissue, and turn everything into plasma. Your complex proteins and DNA would be dissociated almost instantly. Molecular bonds snap, electrons fly off, and atoms scatter. Put simply, vaporization by slow heating might take seconds, but chemical destruction and ionization happen orders of magnitude faster, femtoseconds to picoseconds. A nanosecond is actually huge compared to those timescales. By the time 1 nanosecond elapses, you'd already be a rapidly expanding cloud of atoms and free electrons, intense UV and X-ray emission from hotter layers, and high-energy particle bombardment from the corona and solar flares. So, could you survive 1 nanosecond on the sun? No. You wouldn't be cooked in the ordinary sense. You'd be unmade, atomized, and ionized on timescales much shorter than a nanosecond. The sun doesn't need many joules to erase you. It needs only the right environment and collision rates, and those act faster than chemical heat can.